Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge uncommon words from two sentences. So first let us read this question, then we will check about the constraint, then whatever possible solution could be for the same, and then we'll go ahead with the implementation part with whatever possible edge cases could be there, and then finally the time complexity and the space complexity for the same, where we will also check that if we can optimize it further or not. But that could be easily decided as per the constraints. That if as per the constraint even the brute force works best, we won't even touch it to make it more optimized. But yeah, just for our knowledge sake as well, we can optimize it if it is possible. So let us first read this question. So here in the question, a sentence is a string of single space separated word where each word consists of only lowercase letters. A word is uncommon if it appears exactly once in one of the sentences and does not appear in other sentences. Given two sentences S1 and S2, return a list of all uncommon words. You may return the answer in any order. So now the thing is that you are given with the sentence, and in that sentence we need to check that basically there are two sentences, so we need to check that out of these two sentences what are the words which are common and what are the words which are not common, and we are required to return those two uncommon words as the answer. So that is a pretty much straightforward question, and as we can see that it is easy tagged question, that's why it would be just pretty much straightforward question. And even if we check for the constraints, so constraints are also much lower side, so that simply means that even a brute force solution will work at the best for the same. So now what thing you think about this particular question, means like what is the first approach which comes to your mind if you see this particular sentence? What you need to do is you just need to check that if whatever words which are there, are these common? Apple is common, is common, but the sweet and sour, both of these are uncommon, right? And that is what they are returning. So now here what first thing which comes to my mind was that these words which are there and checking that if it is common or uncommon, what we can do is we can use hashing. So basically here one of the possible solution which could be there is it could be of hashing, means basically putting all the words in a hash map and maintaining its frequency that it has occurred two times, because if it has occurred two times that means it is a common word, right? First would be here and second one would be here. Then same goes for this, same for this, same for this, same for this, right? But this would be having one as the frequency and this would be having just one as the frequency, right? So that's why we can easily check that whichever words have the frequency as the one, that would be our answer. And if you think about the possible edge cases for the same, then I don't think so there is any of the possible edge case, because as per the constraint if we see, so here these are basically starting from one, means minimum one word is always there, or or basically one character is always there, and up to it can go up to 200, right? And both of these means the edge case in the sense I want to say here which could have been that there are no characters present in any of the sentences, but they are already mentioning that at least there is one character, so that edge case is already eliminated. Now S1 and S2 consist of lowercase English letter and spaces, so basically that means that uppercase edge case is also eliminated. Means see how I'm eliminating is just by checking the constraint. This one which is there, that means that empty string which is there, that could have been an edge case. Empty string, right? That could have been one of the edge case, but that is also not there because it is starting from one. So here it is mentioned it is lowercase English letter and spaces, that means uppercase edge case which was there, means uppercase letter which could be there. So now this edge case has been eliminated and this edge case has been eliminated, and S1 and S2 do not have leading or trailing spaces. So this edge case is also eliminated. Means now we don't need to write the edge case that if there could be a leading or trailing spaces, and the all the words in S1 and S2 are separated by a single space. So again this edge case is also eliminated. So as per the constraint, all the edge cases are already eliminated. So we just need to do implementation part for the same. Now here the time complexity and space complexity, as far as I know, as per the hash map which I will be using, that would be order of n, and order of n means both of them, time complexity and space complexity would be order of n for both of the cases. Means time complexity as well as the space complexity, both of these would be order of n, but I'll show you after coding the same. Means I'll explain you, or better I can show you now as well. So basically our hash map which would be there, so hash map would be iterating, better you can say that order of n plus m. Hash map would be iterating over the S1 plus S2, means basically over the length of S1 over the length of S2, it would be iterating. Let us say this is n length and this is m length. So that is what we can take, and that's why when it is iterating over the same, so it will be iterating over n plus m length, and it will be storing n plus m length characters into the same, means just whatever length of S1 and S2 is there. So that's why the space complexity and time complexity, both of these are order of n plus m. So this was about the theoretical part and observation, and even the how we can do this particular question. Now if you want to solve this question in C++ or Java or Python, whatever language you prefer, accordingly for the part of this thing, means because here everything is space separated, right? So in Java, in Python, in even in C++, all three we have some of the inbuilt function which actually takes this space, means we can easily identify that what are separated just with that space. So we can use those functions, inbuilt function, and we can easily go ahead and solve this question. Like it would be in just few lines after using those inbuilt function. But when comes the part that like in interview, if you by any chance you forgot, or by any chance you just forgot to just revise those syntaxes, so it's better that even in practice we go ahead and practice with the knife method. Means rather than using those inbuilt function, or even there could be a case that interviewer asks you that how you can do this without using any inbuilt function, that could also be the scenario. So that's why this question becomes like implementation, completely purely implementation based question, that you should know that how to implement this. So now I'll show you that how we can implement this particular question, and here we go. 1 minute. So here I have coded the same. Now here, so as we are required to return this vector of string, so we are taking vector of string as the answer, and we are taking unordered map, basically a hash map, where string is one of the data types, string is key and value is int, means the number of time it occurs, and empty we have just taken a means basically just a name, not a clean code name, just a name. And we are taking string word at the starting as an empty string. Now we will be, because this particular string is consisting of lowercase letters and spaces, right? So that's why we will be checking that whenever there is a space, at that moment we need to do something, but whenever there is no space, we will be just appending those characters to this word, right? And when there is a space, that means this particular word is completed, right? So that's why at that particular moment we will be just inserting that particular word with its frequency into the map, and then whatever word was there, we will reinitialize it with the empty string. So that is the simplest thing which we can do without using any inbuilt function. And the edge case which we need to handle in this scenario is that, see, this last word which is there, this sweet which is there, right? So this sweet would be done, but it won't be entered into this map, right? Because anyhow after this sweet there is no space, right? they have mentioned in the constraint there are no trailing spaces, right? So because of that, then after this for loop completes, then we need to add that word with its frequency, and the word we need to make it empty so that we can reuse it for this s2, means the other string which is there. And here also we will be doing the same thing which we did for the first string, right? And then at the end, whatever word which is there, we'll just put that into the map. That is the thing. And at the end, what we are required to do on the basis of count, that whose count is equals to 1, that we will be pushing to our answer, and then we will be returning our answer. So this was all the pretty much straightforward as simpler solution which I can propose without using any inbuilt function. And I hope you are clear with the question as well as solution, and I hope you got some of the useful tips as well as per interview perspective as well. So if you really like this video, you can like, subscribe and share this video among your friends. And this was all. Thank you.